Hello everyone, welcome to today's session. Now today I've just prepared a very simple concept in differentiation, basically determining the gradient of a curve at a particular point. And I'm going to present this in a very simple way, and I've just prepared a very simple equation here of a curve. Now, how do you know that you're dealing with a curve? You can tell that you're dealing with a curve by checking at the highest power of the variable that you are given. In this case, the highest power of this x is actually 2. So if the power is more than 1, then know that you're dealing with a curve. And if you are required to determine the gradient of a curve, then you do it as follows. You say dy over dx is equal to, this is how you find the gradient function. You take this power multiplied by this coefficient to get 4, and then you subtract 1 from the power like that. And the second part here, you still do the same. The power is 1 here, so 1 times 8 gives you 8, and then x, subtract 1 from that power, and the last part is actually a constant. When you differentiate a constant, you always get a 0. So we can simplify our gradient function as follows. Dy dx is equal to 4x power 1 plus 8x power 0. Now, remember, when a number is raised to power 0, that number is equivalent to 1. So basically, dy dx becomes 4 power x plus 8. Now this is our gradient function. It's an equation that gives us the gradient of this curve at any point. Now, assume that you have been given a point 1, 2, and you're told to determine the gradient at that particular point. Now you can do the following. You have your gradient function. So dy dx is equal to 4 into, now you replace with the value of x. Remember, this is the value of x, this is the value of y. So where there is x, you can replace with 1, so that you have 4 into 1, and then you add 8. And the gradient function at that point gives us a gradient of 4 plus 8, which is 12. So the gradient of this curve at this point, 1, 2, is actually 12. Now, somebody may ask you to tell what is the nature of this point. Is it a point of maximum, or is it a point of minimum? If that is what you're required to determine, then you can work it as follows. You already have your gradient function, which is dy over dx is equals to 4x plus 8. Now, at the point of a turn, dy dx is equals to 0. At the turning point, dy dx is equals to 0. You now equate your gradient to 0, and you say 4x plus 8 is equals to 0. That gives you the turning point. So 4x is equal to, this gives us negative 8, and therefore divide by 4, like that, your x therefore becomes negative 2. So at the turning point, the value of x is negative 2. So we want to determine what is the nature of that turning point. So we are going to make a very simple table here as follows. Very simple table. This is the value of x. This is dy dx. And then we can have another row here where we are going to demonstrate the nature of our point. So this value negative 2 should appear at the middle there. Then you pick a point on the left of negative 2, say negative 3, and another point to the right of -2, say 0. Now, you replace these values in your gradient function so that when x is -3 and you replace it here with -3, then this becomes -12 plus 8. Now, -12 plus 8 is actually -4. Now, if you happen to replace x with -2, basically this will be -8 plus 8, which gives us a 0. Then the last value, you replace x with 0, and this gives you 0 plus 8, you get 8. Now what we are saying is that the first gradient value is actually negative, so it tells you that basically the curve is moving downward. When it has a gradient of 0, it's basically horizontal, and when the gradient function gives you a value of +8 at a particular point, then the curve is moving upward. So you can see the nature of this curve. It's basically, a curve with that kind of, shape. So basically, there's a point of minimum. It's a point of minimum because of how the curve is actually moving. Now, sometimes you may get an extension of this question where you are required to determine the equation of a tangent at a particular point. For example, we can pick our point 1, 2, and we try to determine the tangent to the curve at that particular point. And we can do it as follows. Now, given a point 1, 2, we can start by determining the gradient at that particular point. And we have already seen that when you try to get the gradient at this point, we are getting a gradient of 12. So that can be our first gradient of a line that will be tangent at that particular point. Now, if this is the curve, and this is the point where we are calling A, which is 1, 2, we can have a line that passes at that particular point. And this is the line that we are calling a tangent line. So we want to determine the equation of such a line passing through that point 1, 2, and sharing that particular gradient. So the gradient of the curve will be equal to the gradient of the line. So to get the equation of this line, which is a straight line, we can pick another point such that you have 1, 2, you pick another point in terms of x and y, and this point will help you to determine the equation of this line. Remember, our gradient of that line is actually 12. So we are going to determine the equation of a straight line by saying that y minus 2, which is change in y, which is y minus 2, over change in x, which is x minus 1, should give us the gradient of that line at that point, which is actually 12. And then we cross multiply both sides by x minus 1, and this goes, and we are left with y minus 2 is actually 12 times x gives us 12x, minus 12 times 1 gives us 12. Now we can take this negative to that side so that we have y is equals to 12x minus 12 plus 10. And this gives us an equation of our tangent line as 12x minus 10. Now remember, this is the equation of a tangent at the point 1, 2. If you are required to determine the equation of a normal line at that point, Now, a normal line is a line that meets the tangent at 90 degrees. So this is our normal line at that particular point. We can again do that and work it out as follows. Let me just erase this part so that I'm able to work it out. Now, remember the two straight lines are meeting at that particular point, and you realize that there is a concept of gradient of straight lines such that m1, which is the gradient of the first line, multiplied by the gradient of the second line always gives us -1. We have already found the gradient of our tangent, which is basically 12. So if we take that to the gradient of the first line, then 12 multiplied by the gradient of the second line should give us -1. And therefore, our gradient of the second line, which is our normal line, should be -1/12. Having determined the gradient of our normal line, we can now still use the same point of 1, 2. Then we pick a general point xy, and we remember to use our gradient of our normal line, which we have already found as -1/12. And we say y minus 2, which is a change in y over change in x, which is x minus 1, should give us -1/12. Then we multiply both sides by x minus 1, so that we have x minus 1 multiplied by x minus 1. So we can cancel this and we remain with y minus 2 is equals to -1/12x. Then this negative multiplied by negative gives us a positive, and 1/12 multiplied by 1 gives us 1/12. Then we can simplify this as follows. We take this -2 to the other side so that we are left with y. So 1/12x negative plus, this becomes positive 2, and this becomes 1/12. So basically, this is the equation of a normal line at the point 1, 1, 2. So we've looked at a number of concepts. We've started with the gradient function, how we can determine the gradient of a curve at a particular point, how we can also determine the equation of a tangent at a particular point, and how we can use that equation of a tangent to determine the equation of a normal at the same point. These are fairly simple concepts, but they require a bit of practice